All right, so we're going to talk about percent yield. Percent yield is the ratio of actual yield to theoretical yield. Okay, well, what is that? Actual yield is the amount of product produced in the experiment. So if you're actually doing a lab in the back of the room and you're doing an experiment on your own, it's the actual amount of product that you actually form in the lab, that you as a student or you as a chemist actually produce. The theoretical yield is a maximum amount produced through calculations. So you're not Superman. A lot of people are going to make mistakes. You're going to have product fall. You're going to have contamination, whatever it may be. So in theory, you're going to have something different. So those are going to get based on your stoichiometric calculations. Okay, so it's a comparison of what you actually get in the lab versus what you should get using your stoichiometric calculations. Okay, so we have percent yield, which is a ratio, the actual yield over your theoretical yield, your actual from the experiment over from your calculations times 100 because it is a percentage. Can you have a percent yield over 100%? Sure. You can have an actual yield that is actually higher than your theoretical yield because due to contaminations and things like that. You can also have a percent yield that's lower than 100 if you lost some product somewhere along the line. So your percent yield can actually be a plus or minus 100. All right, so let's do a problem based on percent yield. Okay, so when potassium chromate, K2CrO4, is added to a solution of 0.500 grams of silver nitrate, AgNO3, 0.455 grams of solid silver chromate, Ag2CrO4, is formed. All right, so what is the percent yield? So let's first do we're first going to actually write a reaction. What exactly took place? So we have K2CrO4 is reacting with silver nitrate, AgNO3. NO3. This is going to be a double replacement reaction. We have two ionic compounds. We're producing silver chromate and potassium nitrate. Let me balance this. We should have a 2 here, which means this should have a 2 here. All right, so now this is balanced. Okay, great. We have our balanced equation. So in my lab, first I was given 0.5 grams of silver nitrate. Great. That's how much I was given. So when I went back in the lab, I actually produced 0.455 grams of this. Okay, but how much should I produce if I did everything perfectly? All right, we're going to have to do a mass-to-mass stoichiometry problem with this. Okay, so we're given 0.5 grams of AgNO3. We're going to have to figure out how much I actually can, how many grams of AgCrO4 I actually can produce. So the only way to do that is compare through moles. So I have to change this to moles. So I'm going to say 1 mole of this is how many grams? Let's figure this out. 169.9 using our periodic table. Okay, now we're in moles of AgNO3. Now looking at our formula, I know that for every 2 moles of AgNO3, I produce 1 mole of Ag2CrO4. But this gets me to moles. Let me cross all these units out. This gets me to moles. I want to get to grams. So I do the molar mass, 1 mole of AgCrO2CrO4 is actually 331.8 grams of Ag2CrO4. Okay, so doing all these calculations, 0.5 times 1 times 1 times 331.8 divided by 169.9 divided by 2 divided by 1 will give me 0.488. I'm going to write this over here. 0.488 grams of Ag2CrO4. So I should have produced 0.488 grams of silver chromate. But in my lab, I only produced this much. Okay, so I have to figure out the percent yield. So I'm going to take the actual yield, what I actually got in the lab, which is 0.455. I'm going to divide grams of Ag2CrO4 divided by 0.488 grams, which is what I should have gotten. Multiply by 100, and I get, I'm sorry, I'm running out of space. What is it? 93.2%, and this is my percent yield. All right, So percent yield, you actually have to figure out how much you actually got from the experiment, how much you did in the lab, and then how much in theory you should have gotten. And that is percent yield is a comparison of the two. So I hope that explains percent yield.